So, you may have heard about quantum computers, these new types of computers capable of doing previously impossible feats based on the principles of quantum mechanics. Well, maybe a few years off of having a workable quantum computer yet, but that doesn't mean we can't talk about 3 technologies that might make them up in the future. But first, what goes into a quantum computer? Well, in a regular computer, the fundamental building block is the bit, the tiniest bit of circuit that either has a current running through it, representing a 1, or doesn't, representing a 0. This is what we call a 2-level system. It may not seem like much, but in great numbers, they can store information, run programs, and do everything that makes your computer run. In a quantum computer, the fundamental component is the qubit. The qubit is a lot like our ordinary bit. It has states 0 and 1, but can also exist in a superposition of both at the same time. This is the principle that allows Schrodinger's cat to be both dead and alive at the same time. This opens up a whole new world of problems that can be solved with computers. Now this sounds great. What does a qubit look like and how is it built? Well, the jury's still out on what the best type of qubit will be. But here we'll look at three of the top contenders of what they will look like in the future and what's being built right now. Trapped ion qubits are based around ions, atoms with electrons removed to make them electronically charged. This means we can hold them in place with electromagnetic fields. For a 2-level system, we can use an atom's energy levels. If we look at calcium, there are usually 2 electrons in its outermost energy level. By removing one of these, we are left with 1 electron, which can be in one of 2 states, which we call 0 and 1, for our qubit. Then we can use lasers to move the electron between the states, or into a superposition. Trapped ions are one of the best understood implementations of qubits so far, but they come with some challenges. For example, they require extremely cold temperatures to operate in, within a few degrees of absolute 0. Otherwise, the electrons have too much energy and act uncontrollably. Trapped ions are currently being worked on by companies like IonCube and Quantinium.
An alternative technology currently being researched are photonic qubits. Photonic qubits are encoded in the basic unit of light, photons. There are numerous ways in which quantum information can be encoded using photons, like the presence or absence of a photon, or in its direction of polarization. Now, if you want to build a quantum computer, you're going to need qubits that can interact with one another, and this is one of the biggest challenges facing photonic computation at the present. Photonic qubits do have some advantages, however, the most significant being that they can operate largely at room temperature. Some of the companies currently working on photonic qubits are Xanadu and SciQuantum.
The third type of qubit we're going to talk about is superconducting circuits. These are circuits cooled to less than a degree Kelvin. And this is done because cooling the circuit has the effect of reducing the resistance of the circuit down to near 0, and this means the electrons in the wire can move freely and the quantum properties of the electrical current can be utilized, allowing you to create a qubit from the current level. Superconducting circuits are seen as one of the most promising potential forms of qubits. It's them you will find the likes of Google and IBM working on. However, they face their fair share of problems, with the need to isolate the system from outside effects and the challenges of operating at such low temperatures. Now, that's not every different type of qubit being tested, but those are some of the technologies that might make up a quantum computer in the future. But which will it be? Well, only time will tell.